So hello and welcome back. The law of conservation of energy says that energy can neither be created nor destroyed, only transferred. The way that we demonstrate this with circuit analysis is that power delivered equals power absorbed. So today I want to give you an example of how I analyze a circuit to prove the law of conservation of energy. So here we have a 5-volt source, and on it we have a 5 ohm and 20 ohm resistor in parallel. And then we also have two resistors in series with the 5-volt source, and their values are 3 ohms and 13 ohms. So the first thing I'm going to do is simplify the circuit, and 20 in parallel with 5 is 4 ohms. So we're now going to have a 5-volt source in series with a 13 ohm, 4 ohm, and 3 ohm resistor. Now that they're all in series, they all have the same current, and the current, based upon Ohm's law, V equals I times R, is 5 divided by 13 plus 4 plus 5. So the current is equal to 1/4 amps. So next we found the voltage across the 13 ohm resistor by using Ohm's law, which is V equals I times R. So that is going to be 1/4 times 13, which is 13/4 volts. The voltage across the 3 ohm resistor is 1/4 times 3, which is 13/4 volts. And the voltage across the 4 ohm resistor is 1/4 times 4, which is 1 volt. So now we can find the current for the 20 ohm, which is 1/20 ohms, and the current for the 5 ohms, which is 1/5 amps. So now using power, so the power delivered for the 5-volt source is V times I, or 5 times 1/4, which is 5/4 watts. The power absorbed for all the other elements is also V times I. So we're going to have 13/4 times 1/4 plus 3/4 times 1/4 plus, we're going to have 2 more for the last two elements. 1 times 1/20 plus 1 times 1/5, which also adds to 5/4 watts, which shows power delivered equals power absorbed.